Yeah, all lectures should have one good take-home, I think, at the end of them. And mine is, don't sit on a train with Caroline, because she invited me to do this talk about 3 months ago. I said, yeah, sure, I'll do that. Imagining a little church hall in the middle of Romney Marshes, you know, and I ended up here speaking to you lot this afternoon, and somewhat more nervous than I might have been. So, thanks, Caroline. I'll get back. Okay, so I'm here today to talk about breast cancer and genes, and looking a little bit beyond BRCA, which is obviously the well-known breast cancer gene that many people associate with breast cancer, but of course the picture is so much more nuanced and complex than that. Caroline's already done my job of telling you about me, thank you. Can I know a little bit about you? Who here's DipION? Oh wow, okay. Using functional medicine model? Using SNPs, using genetic testing, DNA data in practice? Okay, great, thank you. So when I was thinking about how does this work? How do I I didn't get permission for Carrie. I was wondering how does Carrie's talk and my talk, how do they intersect? Well, my sort of view is Carrie's the one that keeps you out of the mud, and if you fall in the mud, I'm sort of the one that might try and help you get out of it. Because I work mainly with people who've been diagnosed with breast cancer and try and help them with future prevention and recovery. So it's a sensitive subject. 15 years ago, I was sitting in a lecture theatre in ION, and Dr. Margaret Ritchie, who you probably know did a lot of the initial research on phytoestrogens, described a woman exactly like me with my diagnosis, and at this point I was about 5 years post breast cancer, grade 3, stage 3, and she said, women like that don't survive. And so that was pretty tough to hear, and even now actually, that was, my body's gone all shivery, and believe me, it went even more shivery in that moment. So I did. if there's anybody here also dealing with a difficult diagnosis, I'm going to be talking about breast cancer this afternoon, and I hope I don't say anything that makes you feel like that. I don't think I will, but clearly, there's a very individual, survival is a very individual thing. So we're going to be looking at some research, but I hope I won't make anybody feel awkward. So when we talk about genetics and breast cancer, I find in clinic at least, clients are very confused about what we mean, particularly if you're talking about DNA data. So obviously there's the classic breast cancer genes that we know about. BRCA1 and 2 are, the obvious ones, but there are some more that are being identified as strongly associated. And they're SNPs, just like the SNPs that we're talking about, that we've been talking about today. And I'm quite interested in the sort of lesser known SNPs, really. And I'll be looking into some of those. Then there's sort of epigenetic gene regulation, which I'm not going to be talking about today very much. But again, that's something we can look at with our clients. So, for instance, often the glucocorticoid receptors can be epigenetically modified and epigenetically changed, and that's a different sort of genetic intervention. And then finally, I think this causes the most confusion with clients, the understanding that the mutations inside cancer cells are not the same as the BRCA genes that we're talking about, that they are mutations that happen inside individual cells, and they're seen in tumour cells, and they're not necessarily even replicated in tumour cells. So it's this, understanding what we're talking about when we're talking about breast cancer genetics. And why did I call this beyond BRCA? It's very worrying how many people are considering, when they've got the BRCA gene, they're considering surgery, bilateral mastectomy. And I think we've got a big job to do to try and help people realise that there are alternatives to that. The BRCA gene is a high penetrance gene, but it's not complete. And that means if you've got it, you don't need to get breast cancer. There are things you can do. And once we understand the mechanism of BRCA, we can help people to avoid it. So we can learn more about other DNA repair genes and look into that. We can look at the oxidative stress and the glycolysis mechanisms in the body, which BRCA drives. So we can look at other ways of dealing with that situation. I'm really interested in this idea of protective genetic signatures, where we know that BRCA runs in families, but we also know that BRCA mutations without cancer run in families. And there's a lovely little study just recently actually was shared, where they looked at 40 women with the BRCA gene, and of the 40 women, 25 had breast cancer and 15 didn't. And of those women, the 25 with breast cancer, none of them had the COMT RS165631 gene, which is present in 1% of the population. And those that didn't have breast cancer, actually 33% of them had that gene, that mutation. And the authors, the conclusion that they drew is actually that the COMT mutation was inactivating the catechol-estrogens. So there's some very exciting things to learn, and again, that just emphasises how incredibly complex this field is and how wrong it is for anybody to say, right, you've got the BRCA gene, this is what's going to happen to you, because clearly there's a lot more to it than that. I think probably the majority of us are more likely to be seeing people who've got cancer but no BRCA, because within the conventional medical environment, those genetic mutations are being picked up more and more, and people are being, shepherded down treatment pathways with those sorts of things going on. And when we bear in mind that BRCA is about 3 to 5% of the population, clearly we're looking at most people. Most people who get breast cancer will not have the BRCA gene. And that's where we can help, looking at diet and environment, lifestyle, and other SNPs, as we're going to do briefly this afternoon. So, just in case I'm starting to sound like I might be an expert in this subject, or I just want to flag up Sir Adrian Bird, who was the Buchanan Professor of Genetics at Edinburgh University, who is indeed an expert and says that really we don't know much at all. And really that's where I'm coming from. I've spent a few months looking at this, into how I can look at it in practice and integrate it into practice, whether it's worth integrating into practice, and I'm here to share some insights, not to say, I know everything about this subject, draw up a chair sort of thing. So we're just going to look at this together this afternoon. So what's an SNP? Well, basically, as far as I'm concerned, an SNP is pretty much a minefield. There is so many variables, as Emma, drew out so very well for us this morning. They're really not very predictable, and really the state of our knowledge is minuscule on this subject. So just in case anybody isn't quite clear about what an SNP is, like me, it's a change in a single nucleotide in a gene, so the nucleotide bases, and it's a change in gene sequence of one of those bases. When the change happens, it creates an allele of a gene, so it creates a gene variation. We all have the same genes, but we might have a different allele. The SNPs tend to, they occur in coding, protein making, and non-coding areas of genes. The non-coding areas of genes are very interesting indeed, because we don't know what they do. So, and they're all about switching things on and switching things off. And there tend to be more mutations in that area, and so obviously a lot to learn there. SNPs frequency tends to be about 1 in 300. Most of us have millions of SNPs. So that puts it in context a little bit. we'll have anything from sort of 2 to 10 million SNPs individually. So our attempts to look at single SNPs are interesting, and when there's a lot of research, valuable, but there's still a lot that we need to learn. Not all of the mutations result in a different protein, and therefore not all of them have a significant health impact at all. They often, I put usually, but it's probably more correct to say often, they act in groups. They might be grouped on a chromosome together, and they tend to work together. Pros and cons of SNPs, these are the ones I found in trying to work with them in clinic. They're very attractive, actually. It's a lovely idea to work with SNPs, because there's this idea that it sort of eliminates guesswork. They are fixed, unchanging, they're inherited down the germline. You have got these gene changes in your body, and the research sort of tells you how your body's going to behave. So very, very attractive for us to put a little bit of certainty in. In something like breast cancer, it really helps if you can, I find it really helps with clients if you can help them to identify the why me factor. So many of them come up and think, why did I get it? And something so attractive, well, you got it because you got this SNP. It can help the client, but again, we have to be careful. It helps compliance. People really get this. If you do make the connection in clinic, people really seem to get it, and they think, oh, I need to do this now, I need to eat more of this, I need to make sure I get my sleep, all that sort of thing. So it can really aid compliance. And focus, when you're diagnosed with a dread disease like breast cancer, what normally happens is everybody you know provides you with some advice about what to do. You also go and look at every possible thing you can possibly do, and you have about 300 options to try and fit in, normally before about 9:30 in the morning. And this, I think, can help with focus. It can help clients to see what's important. Looking at the con side, things I'm sure you know. You can have many genes with one function. So you can look at a gene that is controlling B12 levels, but there might be other genes. So something might be down-regulating a protein, but there might be another gene that we don't know about or haven't had a report on that is up-regulating. So we need to be careful with that. Then we have one gene that may have many functions. So you're looking to change it in one pathway, but while you're changing it, you're changing other pathways. So we have to be so careful that we're not changing things that we don't fully understand. The clinical results, if you just treat genes, and actually the previous speakers have said this today, you really can't treat genes. So I don't know if you've had it, I've had people come to me and say, I've done my 23andMe, can you tell me what to do? And obviously, we need a clinical picture, we often need functional testing to try and see what's going on. Ben Lynch is a classic example he's very, very vocal in saying you can't just go in and treat genes. We have the issue of the underlying data quality. Lots of issues here. If we're looking at dietary interventions, a lot of dietary interventions have never been tested with these particular SNPs. You've got problems with study size. The large studies are not specific enough for your genes, and the small studies that have identified genes are sometimes not sufficiently empowered. So there's we need to look at that a little bit, and we need to judge the quality of the data. And of course, we all have these issues of data storage and usage and price and that sort of thing. So a lot for us to think about when we're thinking about using SNPs in practice. Increasingly, SNPs are going to be used in breast cancer treatment, and I'm seeing that, I think it's very exciting that they're identifying that some people that have an adverse reaction to radiotherapy, it might actually be to do with an SNP. So they're screening for SNPs now, and I think that's very exciting. So a lot to be, there are a lot of ways we can look at SNPs. The way I look at SNPs, so last year when I was doing my master's with CNELM, I went sort of right down the rabbit hole of this subject, and I sort of blew my own mind, and got very grumpy at times. And there was so much to try and deal with, and so much complexity. And then I'm taking a study break, which from my masters, which may be permanent actually. But sometime around Christmas, I tried to come back up for air and really work out how does what I've learned translate into clinic. It's so complex. You can't get this stuff across to clients. I think I was in a sort of like a rabbit in headlight for about 3 months trying to work that one out. How do I make this relevant? And I came back to the point really that with my clients, I still look at diet and lifestyle first. So my clinical experience is that if you go in too complex and too heavy at the beginning, particularly when you don't know your client, you don't know their anxiety levels. When we're dealing with cancer in particular, anxiety levels are already high. You go in with very complex data, very complex treatment plans. You're trying to explain difficult things. Most clients still believe that whatever you say, if they've got a gene that is dodgy, that is not ever going to change, you're never going to be able to change that. So if you tell them that you've got a bit of a problem with this, they've already added that to their diagnosis, and they're thinking, oh, well, no wonder. Yes, so you have to be so careful. These days, I won't do any DNA testing until after the 3rd session with the client. So when I've done really good diet and lifestyle and put things in place, and I've got to know them a little and how I think they're going to handle it. Because I think that is a really sensitive area. And today I'm also going to try and look at how the diet, lifestyle and genetics sort of add up together. So in the case study, typical case study, 38-year-old mum, diagnosed with breast cancer, often comes to me 2 or 3 years after, absolutely shattered, thinking they should be better by now and wanting some help to get back to normal. This particular woman in consultation, she had breast cancer in 2014. She was grade 3, stage 3, estrogen receptor positive. She had a high BMI, despite having been ketogenic for 2 years, she'd plateaued, and so she'd done a lot to help herself. Her digestive problems were better than worse. She was already gluten-free. Big problems with stress and sleep. She feels okay, but tired, and she doesn't really feel well, and she's very worried about that. So one of the things that's really helpful is to do a pedigree with your clients. Before you actually start to dig into DNA, have a look at the family history and see whether it might be a good idea to do some DNA. Because you can explore some things without getting too deep at that point. Are there any hormonal cancers in the family? What else is going on in the family? Are there maybe hormonal cancers down the male line, which often don't show up? Aunts and sisters and that sort of thing. So doing a pedigree can be a very good place to start with your clients, and I recommend it because it can show some interesting insights too. This particular client also had some personal antecedents for breast cancer, which are high birth weight, high maternal glucocorticoids. Her mother was going through a terrible time. She was C-section, she wasn't breastfed, she started her periods very early and had her first baby very late. And she had significant pesticide exposure in her life, which I'll talk about more. And the matrix was very busy. I've pared this down, but the whole matrix is buzzing here, so quite difficult to know where to start. So like a good nutritional therapist, I started in the gut. So we looked at her microbiome, and so again, coming back to those factors, the diet, the environment and the gene. She was on a very low fibre diet because she was actually doing quite a poor quality ketogenic diet, which is a real issue, isn't it, in clinic? That people think that ketogenic means just eating meat and cheese. I'm being a bit, but really, you see a lot of that. She was C-section, not breastfed. very early antibiotics, very high stress going on. But on her DNA testing, she had this FUT2 gene. And interestingly, well, I think very interestingly, the FUT2 gene, the AA allele, is associated with a lack of the A and B blood group antigens. So it's called the non-secretor type. If any of you ever looked at the blood type diet, it's what Peter Danimo talks about quite a bit. And that is associated with lower microbial diversity in the gut. Because the A and B antigens are actually oligosaccharides. So they are fuel for gut flora. So if you're not secreting them, they actually have a significant effect on your microbial diversity, particularly bifidobacter. So a client with FUT2 is likely to have low bifidobacter. We know that's associated with Crohn's and type 1 diabetes, but digging a bit deeper, the dysbiosis is associated, obviously, as we know, with low-grade chronic inflammation, which is in turn obviously associated with cancer, alterations in barrier function, tumour-promoting secondary bile acids. In this study, they were talking about genotoxic metabolites from the changing gut flora, which are inhibiting apoptosis, stimulating cell proliferation. And this FUT2 gene is also associated with raised blood glucose profile, higher dyslipidemia basically, and lower adiponectin levels. So quite a substantial effect here for this client, who not only herself had a lot of digestive difficulties showing up on the matrix, but there was a really significant family history of digestive difficulties as well. So when you're looking at the microbiome cancer, it is linked to local and distal malignancies. So we're not just looking at colon cancer here. There are links with the microbiome and other cancers in the body. And as Emma and Carrie were talking about this morning, the estrobolome and the way the whole the way we process our estrogens in the gut, not just the deconjugation with the beta glucuronidase, but the lovely sulfation it was that you were talking about this morning, which something I didn't know and found very interesting. And then in addition, a healthy gut flora helps us to metabolize polyphenols into bioactive molecules. We'll look at that a bit more, which can directly affect tumour and immune cells. And conjugation of linoleic acid by the gut flora helps to improve omega-3 and 6 ratios, which obviously are linked to breast cancer, as I will talk about. So, an important role in breast cancer. The World Cancer Research Fund report in 2010 found that the overall, in the meta-analysis, found that the data was too inconsistent to link fibre to breast cancer risk. But a meta-analysis carried out in 2011 with nearly 1,700 cases found that there was a significant inverse association. So more fibre, less breast cancer, and an even nicer review, systematic review in 2012, actually found a dose-related inverse relationship. So we can be fairly confident that improving the microbiome can actually help to improve breast cancer risk, and that for this client in particular, that might be a particularly useful thing to do. And again, one of the things with looking at these individual SNPs in this why me picture is, you know, why does someone, a client who's sitting in front of you, who seems to be doing all the right things, why are they not getting better? And sometimes an SNP can give you a really good clue to that, because this person needs a bit more focus on the gut than your average client. So what was interesting while I was looking into this is this sort of emerging field of the breast microbiome. So again, it's not something I've considered in the past, but an observational study of 71 women with benign and malignant disease found very different bacterial profiles in breast tissue between healthy and cancer groups. And another study done on Chinese women with estrogen receptor positive breast cancer took healthy tissue and tumorous tissue from the same breast, so there were twin samples from each woman, and they found very different microbial profiles in the two pieces of tissue. So I think we'll see more about that. There's nothing conclusive to say about it, but it's certainly an interesting area to look at. So the next area I looked at with this client was histamine, which is not the first thing normally that springs to mind when you're thinking about breast cancer, I think. But clinically, she had a history of migraine, real inability to switch off, digestive and sleep difficulties, persistent rhinitis, increasingly severe food reactions that she sort of thought were very strong food allergies, possibly anaphylaxis, big reactions to fish she'd been noticing. So I was quite interested in that. And again, when we looked at the profile, quite a lot of symptoms that looked a bit random down the male side of the family. Looking into it again, so there were sort of migraine all through the family, diverticulitis, constipation, poor sleep, some quite serious mood problems in the family, anxiety, hives, allergies, and I was suddenly thinking, histamine. I wonder what's going on here, and so I started to look at what might be going on, or that I guess piqued my curiosity. The ketogenic diet, of course, does tend to push people towards higher histamine foods, and I wonder whether that has been the basis of her increasing symptoms. Her allergies, really, is it a histamine reaction? What might be going on? And then when we looked at the panel, the DNA panel, she had 3 different SNPs associated with reduced histamine clearance and breakdown. So I had a little look to see what might be going on there. So we know that histamine is an autocoid, so it's a locally acting chemical that tends to activate other chemicals, and it's a immunomodulator. It's released at mucosal surfaces, so it does affect tissue permeability. It's obviously a neurotransmitter which can mediate diurnal rhythm, affecting sleep and stress and what have you, ability to switch off, and it's involved in digestion. So perhaps not surprising, in fact, the Mates and Novak study, which summarises the actions of histamine in the body, is quite mind-blowing, and you can see what an amazing number of effects that histamine can have. But, is it relevant? So histamine does play a normal role in breast development. It's part of it's one of the, it acts sort of slightly hormonally to stimulate breast development. Histamine and histamine receptors are significantly raised in tumour cells compared with the surrounding tissue. There is a correlation between histamine levels in tumours with malignancy and lymph node involvement. And there are low levels of DAO, diamine oxidase, generally found in tumour tissue, which suggests that histamine breakdown isn't going on terribly well in that environment. We know that histamine is involved in cancerous processes. It can increase the likelihood of metastasis, reduce natural killer cell response, but it's a confusing area. The research is very confusing on this because using antihistamines, there have been trials with antihistamines and they haven't been conclusive. And there's a group of researchers looking at the role of histamine in treatment and actually finding that histamine can be helpful in treatment. So it can protect against cytotoxic effects. So where I got to with this is really, where I got to with this is that it's probably important that histamine is controlled, that we need it to be at the right levels, not too high, not too low, and that might be important in breast cancer. So we're looking to support DAO production with the cofactors, supporting histamine breakdown in the gut and in the liver, supporting the gut flora with bifidobacter. So there are lots of synergies that came up with this client as I was doing. I did do this research on one client. It's rather prohibitive. You can't do this with many clients, unfortunately. It was just for because it was part of my assignment. But supporting the gut with bifidobacter is more likely to reduce histamine levels. So that links nicely to the FOOT2 SNP. Gut permeability is more likely to be an issue when there's a lot of histamine about, and obviously reducing high histamine foods. And identifying personal trigger foods. Definitely, people respond very differently to high histamine foods. If someone says to me, "Can you give me a low histamine diet?" I actually don't think there's any such thing. Obviously, you've got the high histamine foods, but it's a very, very individual thing as to what you respond to. We can go back to the gut for histamine, and a happy gut is likely to be a low histamine environment. Short-chain fatty acids inhibit histone deacetylation, and therefore they inhibit mast cell histamine release. Butyrate and probiotics do the same thing. In rats, alcohol increases mast cell activation in the colon, so another reason to keep alcohol out of the picture. IBS is associated with higher mast cells in the colon, and interestingly, in a mouse model, again, high-fat diet plus probiotics resulting in fewer mast cells in the colon. And another fairly recent study linked low serum DAO with lots of different carbohydrate intolerances. So there's lots going on in the gut here, which is to say, come back to trying to support the gut if you're trying to support histamine, a good balance of histamine. Okay, then the other thing that was fairly obvious with this client was long-term inflammatory problems. She had eczema, lots of skin problems. I'm going a bit blank now. But in addition to that, she was avoiding oily fish because of her supposed allergy to oily fish. So because of the histamine response to oily fish. So her omega-3 levels were actually very low indeed in her diet. She had high stress and alcohol as part of her picture, quite a lot of alcohol, relatively speaking. And then she had this FADS1 gene, or FADS1 SNP. There's plenty of evidence to suggest that the omega-6 to 3 balance is important in breast cancer. And in some breast cancers, we see increased metabolism of arachidonic acid, so the pro-inflammatory eicosanoids, by the breast cancer cells. And there is evidence to support the view that EPA and DHA can inhibit tumour growth. Again, that's in an animal model. The data is inconsistent in humans, but I think we know why that is, because it's so hard to measure these things. It's been shown to have anti-neoplastic effects, suppressing NF-kappa B, activating AMPK and sirtuin enzymes, modulating COX, and up-regulating anti-inflammatory molecules. So it's good omega-3 levels are linked, the deficiency is linked to metastasis, but there's some evidence that too much omega-3 can actually result in immune suppression. So it's not about going in there with tons of omega-3, but for this particular client with the FADS1 gene, it's associated with decreased delta-5 desaturase efficiency. So you tend to get this increased arachidonic acid ratio anyway going on. So for this client, that omega-3 ratio is even more important than it is normally. And there are successful studies in humans to show that it can be moderated by diet. So actually paying close attention to the omega-3 and omega-6 ratios and testing for omega-3 to see what's going on can successfully change the picture for clients with FADS1. There was a nice study done on 108 people. Again, these when you get these SNP studies, they tend to be quite low numbers, but they are empowered by the fact that you've got sort of a homozygous group or a homogeneous group of people. So you're looking at the same sort of variables with them. So this study was looking at the FADS gene polymorphisms on colonic fatty acid concentration, and they found Mediterranean diet, which this particular diet emphasised omega-9 and 3 over omega-6, was very successful in restoring correct tissue balance. That was the diet. I'm going to whiz through that. So looking at SNPs and fatty acid metabolism, we do need to look a bit further than the FADS1. So you've got several SNPs involved in this pathway, which could potentially make quite an interesting panel at some point in the future. I'm smiling at Emma. Emma's taking a photo. So, and I'm quite interested in the set of these genes, which are all involved in the successful metabolism of prostaglandins and leukotrienes and the whole inflammatory processes and cascades in the body. So lots of SNPs to look at here, not just FADS1. The next thing, this client had a body mass of 33, and as we all know, I'm sure in the room, it's not necessarily the easiest thing to deal with. We all wish we had a magic wand on that one. It is a significant risk for breast cancer, so every 5-unit BMI increase increases breast cancer risk by 33%. We always have to remember when we say risk, it's what was the risk in the first place, but nevertheless, that is a slightly sobering statistic. But I'm reminded of what you said earlier, there's statistics and there are individuals. This particular client was had been a lifelong low-fat dieter and recently switched to ketogenic, experiencing good weight loss but still padded. So she had been heavier than this. High stress, poor sleep, central obesity, and she had the ADIPO-Q allele associated with adiponectin deficiency. Now, I'm not going to, this is just really for interest. I would not go into a client and say, let's sort out your weight loss. Let's look at your adiponectin. You know, we know that there are lots of things you might do first, but it's quite interesting sometimes to see why a client might have a bit more of a challenge with certain levels. And I find myself wondering sometimes, is it the weight or is it the adiponectin? What is going on? Sometimes, and some of the studies I'm going to look at here shows that we don't know what's chicken and egg. If you reduce the adiponectin, increase the adiponectin, does the weight come off, etc. What we do know is that genetics and weight loss studies are really about as mixed as any other weight loss approach at this point. Primarily, I believe, because they are still, most of the trials are still being done on the eat less, move more model, and consequently we're not really looking at the proper pathways here to do them. So I can't shed much light on that one at this stage, I'm afraid. Adipokines are very, very closely associated with cancer, but I'm gonna move on quite quickly because I know my time is going. Adiponectin is an anti-aging kinase with insulin sensitizing effects, so not surprising that it might be involved in weight, but it also has very interesting effects with cancer, waking up certain of what I think of as the survival pathways, AMPK, PPAR, SIRT1 and mTOR, inhibits proliferation, angiogenesis and inflammation, when it's high, it's a good thing. And Japanese centenarians, for example, have been measured as having very high levels of adiponectin, so we want it. And levels are lower with breast cancer, inversely associated with tumour size and grade. So we can link that quite directly. Adiponectin is reduced by obesity, high levels of sex hormones, exposure to pesticides, glucose problems, and dyslipidemia. So no surprises there. But again, we're left with a bit of a chicken and egg question. Which is causing which. A lovely trial done by Shai in 2008 put 322 moderately obese subjects onto an isocaloric, low-fat diet, basically a Mediterranean diet, but one was low-fat med, one was Mediterranean diet supplemented with 15% of calories as olive oil, and one was a couple of handfuls of mixed nuts every day. And as you can see from the little blue chart there, the low-carb diet actually did best on weight loss and C-reactive protein, but the Mediterranean diet was quite close on weight loss, and it raised adiponectin more efficiently, and also reduced fasting blood glucose, and women had better weight loss. So quite a good study for my client. And the Attica study similarly found the Mediterranean diet was very good for improving adiponectin levels, as well as facilitating weight loss. And then there's a lovely Predimed study, which quite high levels, white postmenopausal women in Spain, that found that the, I think I might have got my studies mixed up there, but anyway, this one was the 15% of total energy from extra virgin olive oil, and they found that they had a lower incidence and hazard ratios with 62% relatively lower risk of malignant breast cancer. So same basic diet, but one was supplementing olive oil, and one was supplementing nuts, and one was fairly low fat. The authors felt it was maybe the polyphenols in the olive oil that were exerting the effect, and certainly there are some aromatase inhibitors among those polyphenols. I also wonder whether just the shift towards the higher fat and perhaps a slightly better insulin balance in the body was also part of the picture, but that wasn't really explored in the study. So coming on to estrogen, which is the last of the areas I want to look at. This client had no history of hormonal cancers at all. There were some hormonal cancers among cousins, but nothing in the generations above her. However, personally, she had significant exposure to pesticides at the age of 7 to 9. And her period started age 9, which is young. I think we all agree that that might have been a little bit endocrine disrupting, something going on there. And she was very late to have her first child at age 30. She's had a lot of estrogen exposure in her life. Moderately obese with severe endometriosis since she was a teenager will have been increasing her circulating estrogens as well. And just one child and not breastfeeding for very long, we know may have increased her overall pesticide retention. So quite a lot going on for this client as far as estrogens are concerned. Not to mention a history of high carb dieting, so sex hormone binding globulin growth as well, lots of naughty hormones running around. Then exposure, non-organic generally speaking, this exposure to pesticides, the areas that I've talked about in her lifestyle. And then she's got the cytochrome peak for 1519A1 SNP, which is the one that controls aromatase. So it's associated with upregulated aromatization. So as if she hasn't got enough going on the estrogen pathways, she has also got this particular SNP. So we know that added to that, obesity, aromatase upregulation is unregulated in obesity, according to the Reeve study. obviously that condition, as we know, is significantly associated with estrogen receptor positive breast cancer in particular, and that inhibiting the aromatase pathway is linked to better clinical outcomes. Managing aromatase, thankfully, there's a lot of information out there about managing aromatase. Not all of it conclusive, but I think we can safely say that grapeseed extract, flaxseed, with the caveats that we talked about earlier, with testosterone, nettles, green tea, and some pharmaceutical, metformin and arimidex, can help with managing that pathway. And aromatase, as I've sort of touched on, is upregulated by pesticides, inflammation, excess adiposity, too much insulin, and alcohol. There's some doubt about the role of pesticides. There's a set of studies. The New York University Women's Health study in 2000 found no association of breast cancer with pesticides. But interestingly, that group of researchers didn't believe their own results. So they went on to do a prospective nested case control study, and they found that they had blood samples of these women throughout their lives, so they could go back and look at what was in the blood. And they found that the women who were young between 1959 and 1967 had higher serum DDT, and that those women had a 5-fold predicted increase in breast cancer. So really, that's very interesting data there. And then a more recent population study in Gran Canaria found was testing breast tissue in a group of 224 women, and those with breast cancer had a very different profile in the breast tissue. So I think we probably all agree that pesticides have a role to play, but what's becoming clear there is that the age when you're approaching puberty is a particularly important time to try and avoid exposure to all these chemicals, and that hot doses in that timing can actually exert lifelong effects on your estrogen behaviour and on your DNA methylation. So those are all the alleles I wanted to talk about today, and I hope you found them interesting. One of the things that I loved as I was going through this was all the synergies that popped up. And you know, when I was looking at this, when I finished, there isn't much here that you wouldn't do anyway for your clients. And, you know, I think you can take a lot of comfort from that. You're likely to look at their microbiome. You're likely to try and influence their BMI. You're likely to try and optimize omega-6 to 3 ratios. You know, you're likely to look at their estrogen pathways. So often when we look at genetic pathways, and you say, okay, so what's upregulating this if you want it upregulating, and what's downregulating this? You say, well, this is just the stuff we do. This is what we do for a living. And I find that very, apart from the cigarette smoke and the tomato leaves with the aromatase, which I don't normally recommend that my clients start smoking to change their liver pathways. But you know, generally speaking, we can actually take comfort in the fact that most of what we do is supported by what we are discovering about the way genes behave. So that has helped me also to not feel so urgent about digging into all this with clients, you know, and trying to get the basic lifestyle and diet going first. But the synergies are here, where we're supporting the microbiome, improves the omega-6 to 3 ratios, improves the efficacy of med because of polyphenol availability. And then improving those omega-6 to 3 ratios can increase adiponectin, and supporting microbial diversity increases bioavailability of polyphenols for aromatase inhibition, and improving histamine detoxification can improve low-grade inflammation, sleep, and may have the potential to improve the stress response. So some lovely synergies out of all of this for the sort of work that we're doing in clinic all the time. So, very, very quickly, the diet that came out of this research for me was a high-fat Mediterranean diet. That's what was supported. So for all those reasons that I've really just gone through. So instead of just saying, well, this client needs a ketogenic diet, because I am quite in favour of moving the metabolism towards being at least keto adapted, and certainly being able to switch very efficiently between substrates, glucose and fatty acids. But the important thing is to keep these vegetables and these polyphenols in the diet, as well as the other nutrient-dense foods that you find on the ketogenic diet. The evidence for Mediterranean diet and polyphenols is that it's associated with lower incidence of cancer via several mechanisms, improving antioxidant pathways, reduce cell proliferation, blocking pro-inflammatory molecules, increasing histone deacetylase, activating transcription factors, inducing apoptosis and/or autophagy, and binding estrogen receptors. So there's so much to be said for the Mediterranean diet in trying to help clients through breast cancer. So, just finally, SNPs in context, they're great for people who aren't, for outliers, people who aren't really, whose bodies don't work properly, is what I quite often like to say. I'm one of those. Good for compliance with clients, I think. Great for personalisation of protocols. They add focus to the clinical picture. Clients like it. And great for curiosity. You know, I'll be learning about this for the rest of my life, I know. They're bad for anxious clients. I really think you have to be so careful with that. They can add complexity when sometimes you just need to say more broccoli. So not, sometimes complexity is not for every client. If you want to generalise, really don't go here. And they sometimes can distract you from more effective interventions that you could be doing more quickly in particular. So be careful with that. And they're really bad for certainty. Believe me, I have become so confused since I have been looking at this area. And I hope I haven't confused you even more this afternoon. But I hope I've just helped to put it in context for you in clinic. Thank you very much.